atoms are building blocks of elements, we know. They are the smallest part of elements that chemically react. First, in the year 1808, John Dalton introduced the first atomic theory, and in that theory, it is described that atom is the ultimate indivisible particle of matter. Towards the end of the 19th century, it is proved experimentally that atoms are divisible and consist of three fundamental particles: electrons, protons, and neutrons. And these three, electrons, protons, neutrons, is the subatomic particles. And then several other atomic models arrived in the field of science to explain the structure of atom. Thomson, the year 1998, that means almost 90 years after John Dalton's atomic theory, Thomson proposed that the atom consists of uniform sphere of positive electricity with electrons embedded into it. How this theory could not explain the atom structure properly, that I already explained. So after Thomson, Rutherford's famous alpha particle scattering experiment in the year 1909 has come up. And then the Rutherford concluded that the atom is made of a tiny positive charged nucleus at its center with electrons revolving around it in circular orbit. And in this Rutherford model, the solar system is resembled with the structure of atom. And further, the electronic structure of atoms, that means distribution and relative energies of electrons around the nucleus, also explained by this Rutherford's experiment. But there are also some difficulties in the Rutherford's model, and then Niels Bohr in the year 1913 improved the atomic model, especially for the hydrogen atom. Bohr calculated the energy of electron in the various orbits, and for each orbit predicted the distance between the electrons and nucleus. And Bohr explained in his atomic models very clearly for the spectra of the hydrogen atom. But this Bohr's atomic theory unable to explain the spectra of multi-electron atoms. That means atoms which has more than one electron. And then the wave character of the electron, this is ignored by the Bohr theory, and that's why this Bohr's atomic theory was unable to explain the spectra of multi-electron atoms. The wave character of the electron is considered to improve the atomic structure. And this Heisenberg uncertainty principle is ignored in the Bohr models of the hydrogen atom. So I explain this Heisenberg uncertainty principle in details. Irene Schrödinger in the year 1926 introduced an equation which is called the Schrödinger equation, and it describes the electron distribution in the space and the allowed energy levels in atoms. This equation incorporates the de Broglie's concept, another scientist de Broglie, wave-particle duality, and is consistent with Heisenberg uncertainty principle. And in this way, whatever the difficulty for understanding of atomic structure using the Bohr's atomic models was overcome by the Schrödinger equations, de Broglie's concept, and Heisenberg uncertainty principle. When the Schrödinger equation is solved for the electron in an hydrogen atom, the solution gives the possible energy state the electron can occupy. And Schrödinger equation introduced the wave function psi. It is the mathematical function, and the electron associated with each psi means that each electron stays in each energy state. So these quantized energy states and corresponding wave functions, which are characterized by a set of 3 quantum numbers, that means principal quantum numbers, azimuthal quantum numbers, and magnetic quantum numbers, and arises as a natural consequence in the solution of the Schrödinger equation. I already discussed in detail in the previous class. Please you go through my previous class. Then you'll understand clearly these quantum numbers. This quantum mechanical model of the hydrogen atom successfully predict all aspects of the hydrogen atom spectrum, including some phenomena which could not be explained by the Bohr's model. And in these quantum mechanical models of the atom, that shell and subshell, that concept are arrived for the explanation of atomic structure. Shell, it is related to the principal quantum number I explained, and subshell, it is related to the azimuthal quantum number I already explained in the previous class. The shells in turn are thought to consist of one or more subshell, and subshells are assumed to be composed of one or more orbitals which electrons can occupy. That means the principal quantum number, it describes the shell, and shell consists of number of subshells, and each subshell has a number of orbitals where electrons can be occupied. The sum of principal quantum number and azimuthal quantum number, this value, if it is lower value, then these orbitals energy also in lowering energy state. If two orbitals have the same n plus L value, then I already discussed that where the principal quantum number n is lower, that orbitals will have the lower energy. So in an atom, Many such orbitals are possible, and electrons are filled in these orbitals in order of increasing energy in accordance with three things. One is the Pauli exclusion principle. That means where the no two electrons in an atom can have the same set of four quantum numbers. And the Heisenberg's uncertainty principles and the Hund's rule of maximum multiplicity. Hund's rule is related to the pairing of electrons in the orbitals belonging to the same subshell, which does not take place until each orbital belonging to that subshell has got one electron each. That means singly occupied. So I summarize and I try to explain atomic structure during the discussion of the Unit 2, Part 1, CBSE Chemistry 11's book, and this forms the basis of the electronic structure of atoms.